Hello students, we are starting the chapter number 12 in physics, which is electricity. So here is a flow chart of the whole chapter to give you an overview. In this chapter we will be studying the concepts related to electricity. We will study how what is current, charge, potential difference, what do you mean by a circuit diagram, what does it consist of. We will study Ohm's law, a relation between a potential difference and a current in a circuit. After that, we will study the resistance in a circuit, the resistivity, their formulas, their definitions, and their SI units. Next, we have the resistances in series and in parallel combination, which is very important for the examination point of view. Next topic which comes is the Jules Law of Heating, which is the heating effect of electric current, and it is given by this formula, which we will come later. Next is electrical energy. We have already done this in class 9th in the chapter work and energy, which is defined as power multiplied by the time. The last topic in this chapter is electric power, which is defined as the work divided by the time. And how do we get these relations? From the Ohm's law. We will all come to this one by one as we proceed to this lecture. So in this lecture we will be covering the detailed explanation of every topic. We will study the circuit diagram, how to put each and every component in the circuit diagram. We will study each and every numerical related to the topics, and of course the NCERT question and answers. So let's begin. I hope it is clear to you. The first term that we need to understand here to move forward is electric charge. Now, what is electric charge? So you all have been studying about the electrons and the protons, and also you have come across that electron is a negatively charged particle, proton is a positively charged particle. But what is in charge? Why do we need it? So an electric charge is nothing but a basic property of electrons, protons, and other subatomic particles. By this charge I can identify whether it is an electron or a proton. So to understand further topics, we need to know the symbol. How do we denote an electric charge? We denote an electric charge by a symbol Q. The unit of the charge is coulombs and denoted by a symbol C. Right? Let's move to the next topic, which is electric current. Now, what is electric current? To understand what is electricity, we say normally that the electricity is a flow of current in any wire or any circuit or any conductor. But more in physics terms, we will say that electricity is a flow of charge. Okay, so current. So in other words, we can say that the current is nothing but a flow of charge in a circuit. So how do we define electric current? Electric current is the amount of charge flowing through a particular area in a unit time. Why area? Because the current will flow through a wire or through any conductor, and it will have some cross-sectional area. This circular thing is known as a cross-sectional area. So in this formula you can see that the current will be defined as the charge only when the time becomes 1 second. Alright. So the definition of the electric current is clear. Let's see what is the symbol of the current that we will use. The current is denoted by a letter I, and the unit of the current is given as amperes. So if I say that the current is flowing in the circuit is 10, I will say it is 10 amperes. So the definition of the electric current is clear. We also say that the rate of flow of the electric charges constitutes a current. By rate I mean time. So whenever we say a rate of flow, we observe things with time. Alright. So this is a diagram of a conductor shown here. This is the direction of the current and this is the direction of the electrons. So the direction of the current and the electrons are always opposite to each other. Now the next important thing which comes here is, what is one electron? So as I have already told you what is a charge is a basic property of any electron, proton, or any subatomic particle, using which I can identify the electrons from protons. So one electron has this much amount of charge present, which is 1.6 into 10 raised to the power minus 19 coulomb, which is very less. And this number is a fundamental quantity, which is 1e is a fundamental quantity and has a fixed value. Now, if I tell you to find number of electrons present in say 1 coulomb of a charge, how will you do that? Using a relation which is Q equals NE, this relation is known as a charge quantization equation. Charge quantization means that a charge flowing in any circuit or a wire is always written as an integral multiple of a basic unit, which is E. So if I have to find N, which is the number of the electrons, I will put Q as 1 coulomb, I will put E as 1.6 into 10 raised to the power minus 19 coulomb, and I will find N from here. So after putting all the values, I will get N as 6 into 10 raised to the power 18 electrons. So these many electrons are present in 1 coulomb of a charge. Right? Let's move forward. So as we have already, as I have already told you about the basic terms here, electric charge, electric current. So till now you need to understand what are their definitions, what are their physical meanings, their symbols and their units. These are very important things to note down here.